How's it going, you guys? It's Scott with Everyday Home Repairs. Today I want to walk you through how to add a new circuit to an unfinished space like this basement or possibly a garage, shed, or even a barn. As you can see, we have a completely unfinished wall. We do not even have studs where we have framing in place. So in this case, we need to use conduit to protect the wires that we're going to be pulling right off my 200 amp square D QO panel at the end of this conduit run. Now, most of us homeowners that are taking on these projects, we're a little bit more familiar with non-metallic or Romex, which you see here, but in this case, we should actually not be using Romex when it comes to conduit. So I'm going to walk you through this actual install with two 4x4 boxes, and I'll be installing two duplex outlets at each of those boxes, but also pointing out along the way, what are those common mistakes that DIY homeowners might make? So let's jump into it, and I'll show you how I position this conduit, and we'll start running those wires for our new circuit. First up, we'll go ahead and take the cover off the 200 amp panel. Remember, support it when you're getting to that last screw so you can rock it away from the surface. Also, make sure you turn off your power, your main disconnect, when you're working inside just to be safe. Removing that knockout, I do need to enlarge it. I'm using 3/4 of an inch EMT. You could use 1/2 inch for this. I just had some extra 3/4 of an inch that I wanted to use, so I need to enlarge this hole to go ahead and thread in that connector. Now this is one way to tighten it up, just with a flathead and knock it with a hammer or your Kleins, and then tighten that up so everything is secure. I'll show you another way here in just a minute. Now once we have that, I'm gonna build out the rest of this run. Starting off, I'm gonna take just another 6-foot section. I'll have a 3-foot section coming off the panel and then 6 foot between the two 4x4 boxes. I'll just use a pipe cutter here. Pipe cutters are super convenient. You could use a hacksaw if you wanted to. You'll just do a couple rotations, then a 1/4 turn tighter, couple rotations, 1/4 turn tighter, and repeat that until you get a clean cut. Just remember, once you cut it, don't forget to ream it out to make sure you don't have any slivers there that might damage the insulation when we pull the wire through. Now I'm going to install the connectors in each of these 4x4 boxes. One of these boxes just is going to need one connector. It's at the end of the run. The other one is going to have both a left and right. So I'll remove the knockouts, enlarging them to fit the 3/4 inch EMT. And then we'll go ahead and thread this in. And this is the second way to tighten these. They do make specialty wrenches, and you will be able to see below this video in the description a link to the Amazon store for these tools that you see during this installation process. But these small specialty wrenches can be pretty darn handy to help you really get those tightened up. The way they work, they have two different ends that kind of attack it at different angles. Depending on your clearance, you can flip out the other end and you might be able to tighten it up a little bit more. Now once those connectors are on, I'll go ahead and take that 6-foot run. I have the one box at the end. I'll tighten that up. I'm not going to tighten all these connectors until I get everything leveled up. Now we'll put that middle box on. And then I have these adjustable supports. Usually you'd use those to hold up like plastic when maybe you're doing drywall work, but they work really good for something like this or sometimes even cabinet installs. Take that little bubble level, make sure everything is level, and then once it looks good, I'll take my Sharpie marking 2 mounting hole locations in each of those 4x4 boxes. And then once I like it, I'll go ahead and undo the screw and remove that section. Then I'm going to take a 3/16 masonry drill bit and a hammer drill, taking my time because this is a pretty brittle brick wall. So you want to take your time to get a nice clean hole, because then we'll be using 1/4 of an inch by 1.25 inch long, so I can use that nut driver. I like these a lot better, and I hand tighten these to get them secure. I do not recommend you use an impact driver. That can just usually cause you to strip out the holes, and then you got to start over drilling new hole locations to get these boxes secure. So I'll just hand tighten these last 2 tap cons, and then everything will be secure on this run. Now for your installation, depending on how long of a run of conduit, you might need additional support like these conduit hangers. Specifically use these if your instance is similar to this because you want it to hold it off the wall. You do not want to pull right against the wall. So I'm going to start pulling the wire through the circuit. It's going to land on a 20 amp circuit breaker, so we need 12 gauge wire. Again, we're not using Romex. In all locations, that's pretty much not best practice. And then in some applications, such as damp or wet locations, that would be actually against code to run Romex inside the EMT that we have here. Instead, we'll use single strand THHN 12 gauge, and I'm actually only going to run 2 conductors, the black for hot and then the white for neutral. If you need a dedicated ground, you would run an insulated green, also 12 gauge, and pull all those through. Very easy pull here, and I will outline why I'm not pulling that ground conductor, but I still am considering needing a ground for the circuit. Now, it doesn't get much easier pulling wire, specifically when you can actually push the wire through. You know you have an overall easy run. So I'll feed that through to the center 4x4 box, and then feed that through at the 4x4 box the additional 3 feet, really paying attention to when it comes into that main panel. And then I'll go ahead and feed that out with plenty of length on both conductors to land those in the box. Then I'll pull some extra length in the middle here, so I'll have plenty for any pigtailing, snip that off. So this is going to be the arrangement of my outlets. I'm going to start off because I'm in an unfinished basement with GFCI protection. I'm going to run the power from a 20 amp circuit breaker right into the gold terminal here for the hot side, or the black wire, and then the silver will go to my neutral. That is specifically in the line side. Then I'll connect this load side to the remainder of the circuit. That will provide power and GFCI protection down to the other 3 duplex outlets. Now, when we're dealing with unfinished spaces, you're going to be using this type of faceplate, and that's going to work great and give you kind of these rounded corners, but you need to do a little thinking through of what wires you need, because I'm going to be doing pigtailing. And also, you need to pre-install these into the cover before you would place that whole unit into the 4x4 box. That would be, as opposed to usually, we would wire up our outlets, we would put those within the electrical box, and then we'd put on a cover. A little different when it comes to this unfinished space. You're going to want to get everything wired up on that faceplate and then join all that together. So sometimes you need to kind of think things through a little bit. For me, you'll see how I'm using Wago 221 lever nuts. This is the type of application where I absolutely love Wagos. I use them for pretty much everything when it comes to DIY electrical, but this type of application, it just makes it so much easier to pull everything together because you're just flipping a few levers at the end, opposed to twisting and putting on wire nuts. We'll start off with just trimming up and stripping off the insulation for these pigtails. Then I'll start with the GFCI side and the duplex outlet. I'll just have one set of pigtails coming out of that duplex, and then take off the Mickey Mouse ears on the yoke to make sure I have clearance when we actually screw down the duplex and the GFCI to that faceplate. 2 of the pigtails coming into the GFCI, that will be on the line side and the load side. I'll have to take tin snips and trim it off just a little bit more on the yoke to make sure everything fits up so I can get the mounting screws and the nuts in place. The little nuts that come with these are nice because they actually have teeth on them and they want to bite in where you don't have to worry about pliers on the backside. So that first set is done, and I will pre-install 3 wire Wago lever nuts. That's the 413, excuse me, before moving on to the second set of duplex. These will just have a single set of pigtails coming from each of them, black going to the gold screw terminal and white going to the silver. And then those will come together again in the 3-wire Wago lever nut. What I try to do is make it as simple as possible, where I'm really only flipping 1 lever to get everything tied into place. Then we'll go ahead and take the screws off this 4x4 box. Remember, you do not want this type of box. That's for a finish walled surface. It's not going to work out as good as this instance if you get that type of metal box. And then we'll flip the switches, and this is the line side coming in. That's providing the line power into the GFCI, and then this would be the load side with GFCI protection. Place that back into the box and then tighten your 2 screws here to get everything tightened up. Everything should pull into place without any types of gaps, looking like this for your finish installation. Just nice fit and finish and clean. Now let's touch on the ground before finishing off and then landing the neutral and hot conductors in our box. With metal boxes, usually you would want to set a pigtail with a grounding screw to the threaded hole that's usually provided with these metal boxes. Then we would pull that with the ground that we have in our Romex, maybe Romex is coming into those boxes, or the insulated green conductor that's coming through the conduit. In this case, why I'm not using a ground, because everything is tied together all the way back to our panel. So we have conduit, EMT, coming out of the panel, rigidly attached to the panel, to the 4x4 box, through this piece of conduit to this 4x4 box. Then we have this plate getting attached to the 4x4 box, and then these actual outlets all have what's called a self-grounding feature, which in this case probably really isn't even needed, because this back cradle that you see, it's called the yoke. The yoke is attached to the ground of this outlet, and the yoke is securely attached to this faceplate, which then bonds everything back together and provides us our ground. Again, check with your local inspector to make sure that this would be okay in your area, and also I welcome any feedback down in the comments. But this rigid connection all the way back to our panel is what's actually providing the ground in this specific case. Not in all cases when you're using metal electrical boxes, but for this specific instance. So we'll finish things up here on the final 4x4 box, really just flipping 2 levers on the Wago lever nuts and then securing those screws back in place, making sure everything is pulling tight. Once that's done, now we're ready to land the hot and the neutral in our 200 amp square D QO panel. Just getting my routing down, and then I strip down the hot conductor, but I want to land the neutral first. So I'll route that one out, again, get my length, snip that off with the Nipix hybrid wire strippers, and then find my screw terminal to go into, which will take a little bit doing just to get the routing down, and then tighten that one down before moving on to tightening the hot conductor on my 20 amp breaker that was already in place. And then once we have it set, we'll go ahead and tighten things down and move on to testing the circuit. So I'll test it out before I put my cover back on. First up, GFCI, testing it with an outlet tester. 2 amber LEDs is good. We have power here. And if we had an open ground, we would only have the middle LED. So we do have ground here at the GFCI. Additional test, this has a button that tests the GFCI protection. Press that, we went ahead and tripped, and we turned off power to this outlet GFCI, but also the subsequent duplex outlets that pull their power and GFCI protection from the load side of that GFCI. So we'll go ahead and hit the reset. See if we have power back on, which we do with the 2 amber LEDs. And we can test power at all the other duplex outlets. And even down on this end, we could use that same button in this outlet tester. You heard it trip again. So I just tested that this had GFCI protection all the way back from this GFCI outlet. So I can reset that and everything's back in business and our installation is good, which we also have a ground even without running that dedicated ground wire. Now you might have seen this house has a little bit more hardware. Check out this battery down here. So this battery is called the EcoFlow Delta Pro Ultra, specifically the Ultra. This is a new unit coming out in January 2024, and this is providing battery backup to this house through the combination of what's called the Smart Panel 2. Now, both of these products are coming out very soon, and it's really opening up from a DIY perspective what you can do at your own home. Now I have a smart sub panel, I have battery backup, I can provide up to 5.6 kilowatts of solar to charge this battery, and it's really lowering the barrier of what you can do to actually power your own home with the power of the sun. If you want to know more about what the heck this thing is, check out this video right here and I'll walk you through all the details over on our other channel called Everyday Solar. So thanks for joining me on this one, and we'll catch you on that next video. Take care.